data, some tax data one is, and we're also having issues there. I think it grows, it looks like it works, so I tell you something. Yeah. Well, I'll see what I see when I go through and test those ones and see what I am glad they improved. No, thank you. I feel like we've got some semester issues. I think that'll be, we just have to figure out how to tweak it. That'll be hard.
Or maybe just take the first four capture of the 6 students and then we'll pass with here. Let me try that.
Yeah, because in the database, I mean, it's summer 2020, spring, doesn't really matter.
Alright, morning everybody. So we're really close to the end. So we'll talk about new stuff today and tomorrow. Then we'll have the final on Thursday. Yep. When you see what it is, I think you'll be less scared about it. So I think Varun mentioned it, but the exams will be in the same order that the classes are in. So this will be at the ungodly hour of 7:30, and ours will be at our normal 10 a.m. So great.
How much did you pay Varun?
I offered to take the earlier one. I could do one day of 7:30. Cool. Aside from that, all the MSD faculty are meeting today, so probably expect to hear some capstone update stuff pretty soon. Just to show of hands, how many people are like pretty happy with where their proposal is at and think they have a good plan for the capstones at? How many people think they're pretty close but need just a little bit more? How many people are like way off? Okay. Cool. So we still have time. No need to freak out, but glad that a lot of projects are about ready to go. Again, I'd encourage you to go ahead and try to get started. If not writing code, at least coming up with detailed designs and plans and all that stuff over the break. So please don't spend your whole break working on capstone, but maybe think about it a little bit. Any other questions before we get started? Yeah.
Is the grading for the final exam, is that just dependent upon how people do it? There's like a curve or anything like that?
Yeah, I'm not going to promise anything, but I have never curved down, but I have curved up. So that's not a guarantee, but it would take something very strange happening for me to curve down.
If you bring like donuts or something, you get extra points.
Nope. Your classmates might appreciate it, but I will not be swayed. Right. Today we're going to talk about how to make effective visualizations by using multiple views of our data set. So on Thursday we talked about using changing view to make our data set, make it feasible for us to look at our data set. And if we have a data set that's huge, right, we can't look at all of it at once, but we don't necessarily know ahead of time what is important to look at, right? So we wanted to allow our users to change what they're seeing over time. So we talked about a few ways we might do that. So we could change the encoding, we could change which rows of our data we're seeing, we could change what attributes we're seeing, all that sort of stuff. And by changing this stuff over time, right, we can look at appropriate views of the data sort of as necessary as we figure out what, we've more clearly defined the goals of our analysis. So changing what we see over time is great, right? But it actually puts a pretty big load on the user because in order for them to make connections between these different views, they have to remember them. So they have to think about what they have seen that they are no longer seeing and how it relates to what they are currently seeing, right? And that's hard. That's a lot of mental work to do that. So we talked about one technique for easing that load when we're going from looking at one thing to another. How could we make that transition, make it more likely that they can remember the old context? Yeah, so using animation so we can see kind of the in-between of the views can help us remember some of that context. But especially if we're doing like a pretty dramatic change of view, it's going to be pretty hard to to exactly remember and exactly compare the two views, right? Because we can't see one of them anymore. So you can imagine like if you are switching the encoding of your data from, I don't know, node link diagram to matrix view, even if you have some nice way of animatingly moving the edges and shrinking them into little matrix points, you still, when you're looking at the matrix, you don't really remember exactly what the graph looked like. Right? So, any thoughts on what we can do to reduce the cognitive load of remembering stuff? Something you asked me to do on tests quite a bit, but I don't think I've ever let you do.
Bring a cheat sheet.
Yeah, so we want basically the visualization, a visualization equivalent of a cheat sheet. Why does the cheat sheet make it easier? Yeah, so when you need information that's on your cheat sheet, right, you just look at it and you have it, as opposed to having to recall it from memory, right? And so that's the same thing we're going to do with our visualizations, is we're going to have multiple views of the data that we see simultaneously. So there's basically two sort of broad families, which is juxtaposition, or superimposing, or superimposition. Okay. And basically, so we can either take our two views and put them next to each other, or we can take our two views and put them on top of each other. Right. And both of these allow us to have either show different encodings of the data or different parts of the data at the same time, right? And this will allow us to see patterns that would be pretty hard to pick out if we had to remember. Imagine if you're trying to show this to your colleague, right? With this, you say, oh, you see that point there, right? Whereas if you have the view changing over time, you say, okay, so watch this point as I click and change it, see how it changes into that, and imagine you're trying to put this in a report or something, right? We need to have both views visible at the same time for lots of applications. So if we use juxtaposition, if we want to show maybe as much data as we can, right? So I just should throw down as many views as I have access to, right?
No.
Probably not. Right? So what's the limiting factor for having these side-by-side views? What's my constraint? Yeah, the size, basically. I have a finite number of pixels to work with, right? Each time I add another view, I'm basically taking pixels away from another view. So I need to be concerned with making sure my most sort of important views have the pixel budget that they need, right? If I try to put too many, right, I'm gonna basically not gonna be able to have the detail I need to draw all the views I want. How about with superimposition? What's my limiting factor?
Seems like clutter might be an issue.
Hmm? Yeah, if I put all the layers on at the same time, I'm not going to be able to pick out what I want. So when you use Google Maps, right, there's a bunch of layers, but there's not 100 of them. There's like 3 or 4. Right? You can turn on the satellite view of the data. Okay, you get the road graph. Not as photorealistic images, but as map lines and depictions of roads. Right? You can put a traffic layer on that. Right? And that's getting pretty close to the limits of what you can include and still, I guess maybe some landmarks, a few landmarks scattered here and there, right? Which hopefully don't interfere with the road stuff, because hopefully they're not in the road, they're next to them, right? So we can fit a little bit more stuff. But if we have too many landmarks or businesses, or try to add other sort of layers there, right, we're going to really quickly overwhelm the user. Right? So there's limits on the number of layers that we can have at the same time. Right. So that's kind of the main idea, right? We want to show multiple things at the same time, so the user doesn't have to remember these linked views. Okay. So this is called faceting. If you know precious stones or whatever, a facet is, or polyhedra, a facet is one side of a shape, right? So if we look at many facets, right, we get a single facet doesn't tell you all that much about the overall shape, but if you look at multiple facets at the same time, right, then you can understand what's going on. So the things we might want to change in our multiple views are the same things we change over time that we talked about Thursday. So we might change the encoding of our data, or show different encodings of the data. So maybe have a scatter plot and a histogram, or the node link view and the matrix view of a graph, something like that. We might show different parts of the data. So I might have a pretty common thing that we interact with a lot. Use Google Maps as an example here. Here we have the little mini map, which is way zoomed out. Right, so we have the whole country here, and then in our so we have these two views of the same encoding. Right, these are both maps of the U.S. Right, and what's changed is what part of the data is visible. So in my little map here, I have the zoomed out version of the whole United States, and in here I have the zoomed in version of Utah. Right, so I have same encoding, different part of the data. Okay. I could, so that's a common use of multiple views. What sort of context am I showing the user there that they don't have to remember? right? I get rid of this view, what is it that the user has to remember that could, maybe be hard to do? So yeah, so they have to remember, especially if I zoom into the street level, right? It's really helpful to have this zoomed out version so I know, is this a street in Salt Lake or is it a street in Atlanta? So, which you could probably tell because Salt Lake Street will be straight and Atlanta Street will be sort of windy, but by including this extra view, right, I don't have to remember that context. Right. So in order for these views to work well together, I need them to be sort of linked in a way so that I can understand how they're connected. Okay. So in this Google Maps example here, how are the two maps connected? The two views connected.
Shows Utah on your map of the United States.
So the viewpoints, the navigation is connected, right? If I move in one of the maps, right, it affects what I'm looking at in the other. Okay? Right? If you can imagine like maybe my selection stays centered in this big map. So as I move around Utah, my big map actually moves a little bit, right? Or if I move, my little box here, I'm controlling what I see in my big view here. Okay? So that's called linked navigation. Okay? So if I can, in the navigation stuff we talked about, so panning, zooming, that we talked about on Thursday, right? If my views are sort of navigable, being able to link that navigation between them is very important. Okay. Another way we can link multiple views of the same data is through highlighting. Okay. So this would be useful if you have sort of two encodings of the same data. So if you wanted to, so if you maybe mouse over a data point in one view, right, it gets highlighted in both views, so you can see that, hey, these two things correspond. Okay. Shared linked navigation and linked highlighting are important for making it clear to the viewer what the connections between the multiple views are. Okay. So yeah, I think that's all the theory we'll talk about for that. Any questions about this general idea of multi-view stuff? It's perhaps more popular and or feasible than it used to be. How come? Yeah, we have more pixels, right? We can draw more stuff with more pixels, right? So, if we have an old CRT monitor that has this much resolution, right? We can't draw as much. Now we have these nice Retina screens. We can, we have all these pixels to play with. Any other questions about the theoretical stuff? Yeah.
This seems very 2D centric. Is there any 3D, I guess, translation, or are these used quite often in 3D as well?
So I don't think so. Laying out the views in a three-dimensional way probably doesn't make sense. But if you have multi-dimensional data, how might you use multi-views? Any thoughts on how this would be useful for multi-dimensional data?
Well, sometimes doing like dimensional reduction first, right?
Yeah. So we've actually seen multi-view visualizations of high-dimensional data in Matplotlib, if I remember what we used. This is just the scatter matrix. So we just had, n squared views of the same data with the same encoding, but we were looking at different facets of the data. So this can be used to sort of manage higher dimensional data. So that sort of general technique where it's where the individual views are kind of too small to look at in detail. The general term is called small multiples. So we have repeated, multiple views of the same encoding of different data. It's called small multiples. So that's a common technique when you have many attributes to look at. All right. So now that we know about all these things, let's talk a little bit about our Kevin Bacon graph visualizer and how we might incorporate these things to improve it. Okay. So remember, got our graph, right? And this shows us some of the data in our data set, right? But it's not showing us all of it, right? There's some other data in here that could be useful to us that's not actually included in this visualization. So what other sort of columns of our data might we want to include in our visualization? So what other fields were in that JSON? The year, so date might be useful. What was the first entry in the JSON object that is also not displayed here? The movie title. Right? We have all these actors, they're connected by movies, but we actually aren't showing anything about the movies. So that might be important. There's probably some other stuff in there, but these two seem like the most important to me. So if we really wanted to explore this data set, it would be important for us to have some way of seeing what the movie entitled. So let's talk about our movie and here. So how could we incorporate these into our visualization? Movie is pretty easy. Just label it actually. So I could just put the movie down here. So I put the movie on the edge. Right. I could totally do that. Right. So what are the pros and cons of that approach? Yeah, potential to get pretty cluttered pretty fast, right? Especially if I have edge crossings, right? It's going to make it potentially pretty hard to read. Okay. About pros. Yeah, I mean the movies are what the edges are, right? It's like probably the tightest connection between the visualization the data that we could come up with, right? So in some ways, it's kind of the right thing to do. How could we avoid some of this clutter? Right, so we kind of know that the edges should be associated with the movies, right? But drawing them on the edges is maybe a little bit is too cluttered.
So it's like interactive. So you could choose which movies to highlight, or like have your like select certain movies and have them be labeled or highlighted in colors. Or something.
So maybe in like have another. Maybe be able to select the movies. So how would these two things interact?
Just like the actors, you know, like more movies that all the actors were in.
Okay, so this will like populate this. Right. So we have a little bit of a linked view here already. Right, this would be a view as opposed to being something particularly interactive, right? And it's linked based on our selections over here. Cool. And over here, so how would we display this? Like how do we want to visualize it? Just like a list. Okay, cool. So we just have a list of movies. So that shows us connection between the selected actors that we have. It's not necessarily connected to the edges though. So it would be nice to have a connection to the edges.
Do some grouping of the actor nodes based on the movie.
So for like the node layout.
Right, so if you've got 3 actors that share a movie, you kind of cluster them together and then have some longer connections outside of
So hopefully we're already doing that. Right? Why would we expect that to be happening with what we have so far?
because everything's spring-based anyway.
So our forced directed graph layout, right? We have springs between all the actors in the same movie, right? So we have cliques for the actors for co-stars, right? So actually our layout should automatically pull those close together. So that's pretty good.
But right now they're not being labeled. Couldn't label them, just put like a bubble around.
So maybe like draw a region around it?
Right.
Okay. So yeah, that's one thing we do. We could put we could use a region to connect basically actors to movies. Okay. So if I draw all these regions, that's probably going to be clutter. Right? So how could I reduce the clutter?
It's only one label per movie rather than potentially lots of the same like movie label.
So if I have co-stars, right, in this clique, right, I don't have a few good men edges between all of the characters all the time. That's good. I just have one label for the region. Right, but if I have 10 movies up there, it's going to get overwhelming pretty fast. So showing this for 10 movies is probably not going to work. So how can we still use this idea but not show it for 10 movies? Ideally, I'd like to show it for one movie. So the user is interacting with this. That's the key thing.
And making a clipping node, you show all the actors.
Yeah, so we can use interaction to limit or to change the views over time, specifically this layer that connects the actors to the movies. So we can, so one way we could select is by clicking. Right? So if I click a movie over here, then I could draw this region. Cool, right? For that kind of selection, You know, the user could select all the movies they want to see, right? And that would sort of put the clutter control into their hands. Right? So that's one approach. What else might we want to do? So maybe we decide a priori they can't select a whole bunch of stuff. So is there another interaction we could use other than clicking? We want them to only be able to select one thing at a time. Yeah, so hovering is another interaction. Right? So we could do the same thing, but when we hover, that's when we highlight, right? And then when we mouse out, right, we turn it off, right? And so there we get one selection at a time, right? So that limits the number of selections that we have. And also, this is a pretty big limitation for modern visualizations that we'd want to think carefully about. Most people are, well, there's a good chance that people are going to interact with your visualization on a device that doesn't have a hover. So when you're working with the touch screen, there is no hover, so we want to think carefully about what to do there. So, all right. So we have this linking, this linked highlighting, or I hover over a movie, and I can somehow highlight something in this graph view that I have in the middle. So that's like a one-way thing now. How can I make it two-way? So if I know the movie, I can see the edges. I can see which edges it's associated with. All right, how can I go the other way? So I have an edge. I want to see what movie it's associated with. Right? How can I link these views?
You can like select a part of the drawing. And then have it highlight kinds of images.
Yeah, I can highlight. I can select here, highlight here. Right. So the same thing. I can use clicks to do that. I could use hovers to do that. Right. But I can. I have this linked highlighting. Right. If I interact with an object over here, right, I can highlight the object here and in this linked view over here. Okay. We're gonna look at the how to do that for the Kevin Bacon data set. Any other thoughts on views or information that might be useful to convey? Cool. Yeah, this is what we're going to work with. I have made a couple of updates since Thursday. Was it Wednesday? Thursday. That incorporates some of these things, and we'll look at how I did that with D3, and then we'll look at we'll add a little bit more interaction to our visualization. So here's our visualization. A couple of changes. So I added this extra view down here, and if we look at it, we have I've added linked highlighting between the edges up here and the movies down here. So we now have a multiple view visualization with linked highlighting. So let's take a look at what we did. So first off, the visualization works a lot better now. So the fix here is related to one of the simulation parameters called the alpha, which, as best I can understand, the nodes get slowed down every frame, so their speed gets multiplied by some number less than 1, and then slows it down. So we, over time, the simulation will slow down and stop. And so when we were restarting the simulation, we actually had to bump that alpha value back up so stuff moved again. So I'll show you. So here, everywhere we restarted, we basically just add this this alpha target piece in, and that's why things were stopping, because their velocities were being scaled by 0 each frame. Cool. All right. So next thing we'll talk about is the timeline view here. No, it's not. Should be drawing the years with these ticks, but seems to be working. But this is making use of a cool D3 tool called the Axis, which is a part of the library for drawing these axes based on with tick marks and all that stuff, which is pretty handy. And then it gives us a way of basically taking our data in its like data form and scaling it appropriately based on the axis. So it's kind of handy. Let's take a look at how we did that. So here's our timeline. Okay. So the first thing we're going to do is decide what time period we want to show. So when I came up, my approach was if we have edges, I want to show basically the range of movies in that time period, right? Plus a little bit of slack. And otherwise, we'll show the time period for the whole data set, right? So we don't have any nodes that are connected, right? There's no movies to list, but we just want to show basically the range of Kevin Bacon movies. So our timeline is actually going to expand and shrink as we add more movies. Yeah. So here we're doing is we're taking, so if there are active edges, I'm going to look at the years of the movies in that. Otherwise, I'm going to look at just the years for all of our movies. Okay. This reduce thing here is just basically the min function. I'm just looking at trying to find the minimum year in my array of either edges or my movie data set. And then for whatever reason, it's a string in my data set, so I'm going to convert it to an int. And then the end is the same, except I'm using basically the max function instead. So, so this is the range of dates. It's either going to be the earliest and the latest Kevin Bacon movie or the earliest and latest movie that is currently being drawn as an edge. All right. And then, so this is a handy D3 thing here. So this is a scale, which basically you say the range of input values that you have and the range of output values and how to map them to each other. And this is a function that will take one of the inputs and give you the corresponding output. So in this case, if my my range goes from 1980 to 1982, if I input 1981, I get somewhere in the middle. So I get I would get like width over 2 or something. So this is a handy thing, and yeah, it's just a function that gives me that takes a date as input and gives me basically a pixel values. And then the axis is is basically the function for drawing the lines and the tick marks. Okay. So it takes as input the scale, so it says basically what range of dates are involved here, and then also how much visual space should I draw this in, like how many pixels wide should this be, that kind of stuff. And here I'm saying that I want the tick marks every year. So you can do all sorts of stuff. Say I want 10 tick marks, and it'll space them out for you. You can say I want tick marks every month. You can really customize basically how this stuff is drawn. Here we just want to draw the years. And then if so the first time I call this, I don't have any SVG elements for my timeline for the ticks. So if I don't have that, I want to create it. So I'm gonna basically it's just a group SVG element, and then D3 will add all the lines and text inside of that group to draw the timeline. So, so I'm just making a group element in my so this box here is my timeline, just blue SVG. So I'm just putting a group in there for the timeline, giving it an ID so I can grab it later, and then moving it down a little bit so that the numbers aren't drawn off the SVG. And then to actually draw the tick marks, I basically call this axis function on the SVG element that holds the timeline. So this basically says draw all the tick marks in that element. So this is all the code basically needed to draw this part here. And as my date range changes, right, my scale is going to change, so my ticks are going to change along with it. All right. And the next thing I want to do is actually draw the text for the movies. So in my little timeline window, I'm going to select all the text elements, which again, when I start, don't exist. Okay. And then the data associated with that is the current edges. So for any edges that don't have an associated text thing yet, right, I need to make a text element for them, set the text to be the title of the movie. This style here is a CSS thing for drawing the text vertically. So this TB stands for top to bottom, so that's how I got the text to be vertical. It's kind of handy. The position, the X position, I'm going to take the date of the movie. So this is the year the movie came out. This is making a date object. And then my scale takes my date and gives me back basically the pixel position of it. That's kind of handy. And then just setting the Y the same for everything. And then to do the linking, I add mouse events for hovering and mouse leaving. So I And then when I update, so as my scale changes, so any movie titles that already existed, right? If my scale changes, I need to update their positions, and so that's what I'm doing here. So I'm updating. This is the exact same code as I had up here, right? The difference is that my scaling function has changed since the last time I drew this, so things are going to move. So if I comment these out, we'll see what happens. So as I draw new movies, you see dragging to China is, digging to China is duplicated in the wrong spot because the scale changed, and I didn't update the previous elements. All right. So this is kind of a typical sort of plotting thing, right? So whatever my marks are, I can use D3 to make elements for each mark. I can use my scales to position them based on the current zoom level or whatever, right? And then I update these as they go. Cool. So any questions about that? So we've drawn this timeline and positioned the things in there, and they move as necessary. So now let's talk about the interaction. So as I hover over one of these edges, right, I'm highlighting the movie associated with it. So let's talk about how we make that interaction happen. So which part of the code, so where in the code do you think we want to deal with this hovering? So we need to attach an event handler for basically the mouse enter and mouse leave events. Okay. And when would be a good time to set that up? Yeah, so when I create the edges, right, as I create them, I'm specifying all their properties. One of the properties I want to specify is what to do on these events. So we go up to, this is the part where we're creating all of our line elements. These are our edges. Basically what we've done is I've added here on, I've added these listeners. So when the mouse goes over one of these lines, call this function. When the mouse leaves one of these lines, call this one. So let's take a look at what those handlers are. So here we have the mouse over the edge. So this is going to be called when I start hovering over one of these lines. Okay. So the first thing I'm doing is I'm highlighting the line I'm hovering over. Okay, so I'm just setting the stroke width to be bigger. Right? And then I need to link this highlight to the other view of my data. Right? So I have highlighted my edge in my node link diagram, but in my timeline, right, I want to highlight the the data that I have. Right? So I need to basically select all of the, right, I need to select the corresponding movie in my timeline, right? And I can do that with D3 with the filter. Right, so I'm going to grab all the text nodes in my timeline, and then I'm going to filter that. Because I created these text elements with D3, they actually have data associated with them, so I don't really have to look at the SVG text or anything like that. I can look at the data that I connected with them and see if the movie is the same as the edge that I just clicked on. So maybe let's look at kind of the two pieces there. So first off, I hovered over an edge, which is an SVG line element. Right, the line doesn't say the movie name anywhere, right? But because I used D3 and I connected the line with data when I made it, I can actually grab the data associated with that line and see what the movie that is responsible for creating that line. I can get the movie name out of that, and then my timeline entry also has data associated with it. They come from the same array of edges, right? That I can look at the data that way, right? So I'm filtering. I'm getting all of the text elements with that movie name, which we think is probably just going to be 1, right? And then I'm going to boldify it. So does that make sense? Right, so this is my linked highlighting, right? I'm grabbing the corresponding element from a different view, which D3 makes pretty easy, right? And then I can modify the attributes to highlight. Right? And then when I do a mouse out, when I leave the edge, right? I want to undo that highlighting for both of them. So this is referring to the line in my node link diagram. I'm going to set its width to be back to the original, right? And then I'm going to kind of be inefficient here. I'm just going to grab all of the text elements in the timeline and set their font weight to be normal. So here I'm applying the font weight to every single text element, even though only one should be changing. Cool. From a software engineering perspective, I've done something pretty awful here. Why is this like really, really unmaintainable? I have a bunch of magic numbers here. Let's say I change this number here. So when I leave my edge, I'm setting the line width, right? What happens if I change this 3? My line is going to be different after I leave it than it was before I started. Okay? If I want it to be the same before and after I start, I have to change it here and where else? Yeah, so up here where I created my line, right? I need to make sure that this value matches the value here, right? Otherwise, otherwise things are going to be weird, right? So I really should have, selected and normal, properties for my various elements that are specified in one place, right? So that this doesn't turn into just a mess of magic numbers and all that stuff. But for slideware. Hopefully this sort of shows you the core concepts. So one thing that you may not have noticed, so look very closely as I mouse over and mouse out. Does anybody notice anything? It gets fatter, so I hover over, and as I mouse out, notice anything sort of unexpected? So it doesn't snap immediately to thin again. It loses weight over time. A nice subtle animation there. So I'm using the D3 transition tool, part of the library. So anytime you apply a new attribute, it's really easy to make that attribute come in over time. Okay. And so we'll take a look at that. So this can be really useful if you're like moving an element. If you basically you just stick dot transition in there, and instead of popping the element somewhere else, it will move it over there, and you can control basically whether it goes there just linearly, whether it accelerates and decelerates over there, all sorts of cool stuff like that. I have here making a transition. So I'm saying over 500 milliseconds, I want you to just linearly go from one thing to the other. So basically anywhere where I'm like changing an attribute, I just slapped this thing in there, and it makes that fade happen over time. So I'll show you an example. Right, so I have Kevin Bacon over here, and if I unclick Kevin Bacon, everybody see that? Look at Kevin Bacon. So he fades out nice and slow. So what I did is before I removed the node, I set all of the colors to white with the transition. So it's all the colors are slowly changing from blue or black to white. And then when he's completely white, then I actually remove the node, and it's removed from the view. So with D3, it's really easy to add these sorts of animations, so you can make it obvious like when stuff's happening. Cool. So that's so this I'm creating this transition object, and then so here so this is my for my edges. I've added this part here. So when I have an edge that I have a line element and the data associated with it is no longer in my active selection, so this line should be removed. I'm going to, over a half a second, I'm going to change the stroke color to white, and then I'm going to remove the line from my thing. So we haven't seen this yet. So by default, when you have elements whose data is no longer around, right? You remove an element from your data array, and you redo this join. They're just by default removed, which is a handy default. But you can do all sorts of useful, cool effects by fading stuff out. I did the same thing for the nodes, right? So I set the stroke attribute of everything to white over time, and then I remove it once it's over. Cool. So that's how we can add smooth transitions between stuff with D3, and then we have this one-way linked highlight. Right? So now we want the highlight to go the other way. So we've seen, right, if I hover over here, it bolds the stuff at the bottom. So let's look at how when I hover over here, I bold the stuff at the top. And so when I look at 40 deuce, those are the actors. Here's the if you get men actors. Okay. So that looks very similar, right? When I make my timeline text elements, right, I add listeners for mouse over, mouse exit. And my mouse over, I set my font to be bold. I select all of the lines in my node link diagram. I filter based on whether the movie in the data that's associated with that is the one that I'm looking at, right? And then I set the stroke width to be thicker. When I mouse out, I set my font weight back to be normal, and then I set all of the stroke widths to be thin. Again, I could filter here again, and maybe it'd be more efficient, but I'm just setting all the stroke width. I think most web browsers, if you set a CSS property to be the same thing it was before, I think they're smart enough to not do anything. So I think this is actually not super slow, but yeah, we could do better. Cool. So questions about this linked highlighting? Okay. Yeah.
Just with the select that you have there, D3, is it looping through all the elements and trying to select a line? Or do you think it just stores all the lines in your place?
It's probably using DOM calls. So it's probably doing, document.select stuff. I'm not just selecting all the lines in the image. I'm only selecting the lines that are in my canvas, right? So this is going to be, less expensive than if I had just done d3.select all line. So I don't think this is super inefficient here. Cool. All right. So are there any other linked highlighting things that we think would be useful for this? So we have the edges and the nodes, right, and the text. So I thought it would be useful if I hover over an actor. I would like to see all of the movies that they've been in, right, in this timeline view. So let's go ahead and we'll add one more highlight highlight thing to our visualization. All right. So where are we going to want to put this? So I want to hover over this, and I want to see all the movies light up. Mm-hmm. And which part of where do I want to attach that handler? So when I make my nodes, right, I want to add an event handler for doing that. So here, this is where I'm making my nodes. Remember, I made the nodes as a group element, and the group has a circle and a text in it. So we'll add the event handlers here. I'm adding handlers for mouse over and mouse out. And we'll go ahead and fill these in. So when I put the mouse over a node, what should happen? So we could add a new layer and draw something on top. I'm not prepared to live code that. So we're going to do a simpler.
Could you just highlight it in your timeline?
Yeah, so I want to highlight all the movies in my timeline. So that's one highlight. And what should that be linked with? So I also need to highlight this node, right? So I have a highlight in both views that are corresponding. So to highlight this one, maybe let's set the circle fill color to be like green or something. So we can do that. So if I select this, this should be my group object, right? And then within my group, I want to get my circle. Right. And then I want to set the fill to be green. Cool. So let's see if let's first start with this and make sure that it actually works. Very cool. All right. So partway there, when I mouse out, what should happen? Should set it to white. Again, bad software engineering. I should have the normal and highlighted stuff stored in one place, but here I'm scattering it all over. That's good. So I have this part here where I'm changing my the text to green when I add new stuff. I'm gonna go ahead and get rid of that because it is not very useful here. Get rid of that. Without Kevin Bacon, things fall apart. Let me see that. Okay. So now I have my unlinked highlighting. Cool. And so let's get my links in. So in addition to setting this circle color to be green, what else do I want to do? So now I need to select my timeline, right? And let's see if I. Okay. So first I'll just save the actor. So how can I get the actor? Oops. Sorry, this should be in my. So I have a node that I just moused over. All right, how do I get the actor associated with that? The same thing. So so there's kind of two ways I can do it. One is I can get the text field out of the element, right? So I can just look in the DOM and get the text, which in this case will work because the text I'm displaying is the name of the actor. But I can also use the data that's associated with this node from D3 and get the actor out of it that way. So we'll do that. So we're gonna grab the data field out, and and it looks like the field in there and the data that I want is called name. So maybe to make sure we got the name right, we'll just console.log that guy. Okay, Kevin Bacon in here. Console. And yes, Kevin Bacon, great. So I did get the name. All right. And then for how do I get the corresponding movies? It's kind of tricky. Is there any association between the actor and the movie titles as far as D3 is concerned? Let's look at what data is associated. My active edges has the source and target actors, or source and target nodes. All right. So I think we can get the data that way. So we're going to look at our data, right, and keep the data if the actor is associated with that edge. So we're going to select all of our text in our timeline. And we're going to filter. We're going to only keep stuff if the data, if the edge, either source or target, is the actor that we want. All right. So these are the nodes that we want. And then we'll go ahead and make these bold. And there we go. So let's go ahead and try that out. And if we hover over Kevin Bacon, looks like that did not work. So any thoughts on how to debug this? This is kind of a tricky thing. There's not like an obvious place to put like printf type stuff. So what I found is a handy way to do this. There's this each function that calls a function on each element that you're looking at. So what I've been doing is just putting some console.log. So I can see, what my filter is doing and get some information about the data. So let's go ahead and try that. Forgot some punctuation here. Success. So if I hover over Michael Gross, we just have Tremors. Jack Nicholson should give me A Few Good Men. Kevin Bacon should give me Everything. So we have that linked highlighting. Now all we have to do is just undo it at the end. Again, we're going to do the sort of hacky approach. We're just going to set everything back to cool. So that we now have linked highlighting. We have linked highlighting. Every time I hover over one of these movies, I can see, or hover over an actor, I can see what movies they've been in. And there we have it. Cool. So we have multiple views, linked highlighting, looking at different attributes of the data. Right. So up here we're looking at the actor in the movie using a node link encoding. Here we have a timeline view of the movie, showing the movie and the date. Right. And we have highlighting that shows the correspondence between the two views. Hopefully you can see there is immense power in doing this. This is something, there's no matplotlib view that would have done this for us, right? And the fact that we can interact with it adds a whole lot, right? This linked highlighting on demand is pretty huge. For the downside is that there's a fair amount of code involved in doing this. It was it's not too bad. Let's see, we have about 300 lines. A D3 definitely makes it shorter than it would be to do totally custom, but there's a fair amount of work in doing something like this, but we get really big benefits. So, any other questions on this multi-view stuff?
I was just wondering if you knew of any frameworks that kind of do this sort of thing, but not in
JavaScript. There might be some sort of general visualization tools that you can kind of do plugin stuff for some of this, but I am not familiar with them. JavaScript is probably going to be the most common just because there is a good interactive canvas thing for you to work with. Right? Otherwise, it would be tied probably pretty closely to a different visualization or a different like GUI framework. So, use the Mac OS Quartz, whatever, or something like that. So I think probably JavaScript is going to be one of your best bets. yeah, otherwise it'd be sort of tied into something more purposeful. All right. So tomorrow we're going to talk about 3D visualization. So we're going to look at some cool 3D renderings. And then Thursday we'll do exam. So, see you all tomorrow.